I'm Professor S.K. Parvatikar, selection grade lecturer from Mechanical Department. Would like to give from Moti Chandengde Bhartesh Polytechnic, Belgavi. Would like to give a video presentation on the course named Mechatronics for the 5th semester students. It is important that we require to understand what is the Mechatronics course, as this is definitely a new course, especially for the 5th semester students, because it is because whatever you have learned till 4th semester, it is totally hardware based. So now you are going to learn about the uh, some touch up with the electronic concepts. So that is why we can say it's a mechatronics. So let us have a brief discussion before we actually start with the different chapters. So what all you are going to learn in your course, you'll be having total number of units 6, means you are going to have 6 chapters, and the weightage of hours as mentioned is 7 hours, 11, 6, 10, 11 and 7. So total number of hours to be completed is 52 hours. And the most important thing that you require to note is marks weightage. So depending upon your capacity of remembering, depending upon your understandable level what you are going to have now, you can choose the chapters also, if at all you want to go for the scoring, if at all you want to go for the passing. If you observe keenly, the first 4 chapters weightage is 30 marks. That means 30 marks is allotted for the first chapter, 30 marks for second, 30 marks for third, and 30 marks for fourth chapter. And for the fifth and sixth, you are going to have 15 and 10 marks respectively. So total number of marks available for you to answer is 145, but you are going to answer for 100 marks depending upon your capacity and everything, whatever is there. So that is why it is important to note that you have to decide how best you are going to involve yourself in getting good number of marks in the examinations. So totally you are going to have 6 units as I've already mentioned, and let me start with the presentation on the first chapter, that is mechatronics, sensors and transducers. So when we speak about the mechatronics, in this particular video presentation you'll be learning about these concepts, that is what is mechatronics, importance of mechatronics systems, types of systems, that is measurement systems, control systems, and in control systems you'll be having open loop control system and closed loop control system. So when we speak about the mechatronics, if you are going to see the concept of mechatronics, actually the concept of mechatronics was introduced by the country Japan, uh, which is a master in the field of electronics. So as the name itself implies, mechatronics, it is a combination of mechanical and electronics with some computer control technique or the system. So whatever the advancements that have taken place in the field of automation, it is all because of the mechatronics. So previously we used to have only the hardware based systems. Now you are going to put the automation system into the field of mechanical engineering course. So means mechanical engineering field. So if you are going to see the advancement, what is happening in the industries, in almost in all the industries, you are going to have automated production lines, automation process, and whatever the production is going to take place, whatever the product that is being produced, it is being produced in an automatic way. That means automation is the main criteria there, which is being introduced in each and every industry and the process industries. So we must have to understand now, when we speak about the mechatronics, as I'm telling, mechanical plus electronics is called as a mechatronics. So don't write in the examinations when they ask define mechatronics, don't write like this. It is a combination of mechanical and electronics. It is a, don't write that we are going to add. So you require to define correctly with the proper technical words. So what we are going to consider here is mechatronics is defined as an interdisciplinary approach. Interdisciplinary approach because there is advancement is going to take place in all the fields. It may be in mechanical field, it may be in electrical field, it may be in electronics, it may be in computer science. So all these interdisciplinary branches of engineering have been combined, have been used in combination so as to build the mechatronics components. So that is why we can define like this now. Mechatronics can be defined as an interdisciplinary approach to engineering design through an integration of mechanical engineering, electrical engineering, computer technology, electronics, and control engineering. So as you are going to see, all these are involved. So all these have been encircled. You are going to see at the middle of the circle as mechatronics. That means you are going to have mechanical systems, you are going to have electronic systems, you are going to have computers, control systems. So all are combined, all are used there to go for the mechatronics. So when we speak about the application of mechatronics, it is important that, as I already told, some of the examples as you are going to consider, suppose if you consider the application as a commercial, you can consider as automated washing machines. And if you consider in the field of production or manufacturing, the robots. And if you consider in the field of automobile engineering, you are going to come across a smart suspension system in trucks. And if you consider in the field of engines, you are going to have digitally controlled combustion engines, navigated vehicles. And if you consider the production line, you are going to have automated production line, etc. So these could be the various examples. Okay, even in the design of cars, machine tools, washing machines, cameras, medical equipments, flexible manufacturing systems, air conditioners, integrated manufacturing systems, all in all these things, there is an interdisciplinary approach to engineering design. That is what we call it the mechatronics. Okay, and the major, then we come across what is the importance of this mechatronics. We should know about the importance of mechatronics. So when we feel about the importance of mechatronics, it is important that we are going to consider we are going to consider various advantages, or which is coming under as a part of your mechatronics itself. Okay, that is already I have defined about this mechatronics. It is an integration of bringing together a number of technologies like mechanical engineering, electronics engineering, electrical engineering, computer technology, and control engineering. It is a term used for the integration of microprocessor, control systems, electrical systems, and mechanical systems. Examples, I already told, in all the fields we are going to have all these different examples. Okay, we can just go through them, and let me start with in what way we can consider that mechatronics is more important as far as the present technology is concerned, because it makes the system more reliable. When we speak about the system, again we are defining what do you mean by a system, what are the different types of systems in the future slides which we are going to learn now. But anyway, it makes a system means it makes the entire process, it makes the entire machine manufacturing, it makes everything more reliable. Reliable means what? Suppose if at all we want to go for if you consider the production efficiency, the production efficiency can be achieved to the required degree by the industries. This is called as reliability. Okay, so there is no question of stoppage of production. The production gets continued continuously because of the mechatronics, because of the integration of the field of automation into the mechanical and electronics. Like, it makes the system more flexible. That is very, very important. We can go for the flexibility. That means whatever the changes that we require in the production or in the field of any process, it is possible to go for that. And the next one, very important, is high quality of manufacturing a product with less cost. This is very, very important, because as far as the application of mechatronics is concerned, you are going to achieve a high quality of manufacturing because we have put it into the automation. There is no question of rejection of the product, and whatever the product that is being produced because of the less cost, the number of workers working, okay, on different machines can be replaced by one automated machine by with a single operator. So that is how we are going to reduce the manufacturing cost, and it makes the system more versatile. Versatile means what? Expansion. You can go for the expansion of the system. You can go for the renovation of the system with the integration of the automation or mechatronics components. It makes the system highly controlled. The controlling technology, the controlling technique that is being used in industries also is very high. Means it can be achievable at a higher degrees compared to the if you just rely only on hardware based technology. It makes the system more cheaper. The entire system becomes cheaper. Okay, that means it is less costly compared to if we do any type of production, any type of process, okay, with 100% aim of efficiency of getting the efficiency of production. It may not be possible if we have different labors with different skills. Okay, so that is why it is important that it is possible to make the system more cheaper. Okay, so this is about the importance of mechatronics system. And the next important, so let us have a definition of a system. So we speak so many things about the system. When we speak about the system, it is very very important. So to give you a very simple practical example, when you are going to take up an admission for the diploma course, okay, you will be inducted through your academic performance in your 10th standard. Okay, so that is called as an input, and whatever that is going to happen in the entire 3 years is called as a process. And output means whatever that you are going to get in the form of your diploma certificate. So that is how we are going to consider as a practical example. But that is the same thing is applicable even for your systems. When we are going to come up with the definitions, a system can be thought of as a black box which has an input and an output. There are two important uh, parameters here. One is an input and the second one is an output, and some process is going to happen in a system. Okay, that processing is going to take place. We are not concerned with what goes on inside the box, but only the relationship between the input and output. We are bothered about the relationship. So that is why we have taken an example. A very simple example is taken as an electric motor. A motor may be thought of as a system which has an electric power. Without electric power, the motor is not going to run. We require to give a connection to the electric motor, where we require to give the electric power to the motor, then it runs. That running, whatever that running is there, it is in the form of what? The output. That is what we are going to consider, that rotational speed of the shaft. So we are going to give the input of electric power, then you are going to get the output as a rotation of the shaft as an output. So this is called as a simple system. Okay, now when we speak about the systems can be of two important types. You require to remember the systems can be of two important types. The first one is called as a measurement system, and the second one is called as a control system. So when we speak about, so as the name itself implies, measurement system, basically it is concentrating on the measurement of a particular parameter. Measurement system, for example, in an air conditioning system, if you take, okay, then you are going to measure the temperature. At the same time also you can control the temperature also. But whenever we want to go for the measurement of a temperature by using a thermocouple, it is coming under the classification, or it is coming under the as a measurement system. So now there are two important types. One is called as a measurement system and the second one is called as a control system. Again we are defining with the same words with a slight change in the definition. If you just consider the previous slide, a measurement system can be thought of as a black box which can be used for measurements. A measurement system can be thought of as a black box which can be used for the measurements. Whenever I want to go for the measurement, we call it as a measurement system. Example, a thermometer may be a temperature measurement system. A thermometer, a simple thermometer, we consider it as a temperature measurement system which has an input as a temperature and the output as a is a number on a scale. You are going to measure, because the scaling is, that's called as the graduated scale. You are going to see on a scale how much movement is taking place. Okay, sometimes even your the thermocouple can also be considered as a measurement system. Okay, so in a thermocouple, what happens, you are going to give an input of temperature to the thermocouple, then you are going to get the output in the form of EMF, electromotive force, then you are going to amplify it, amplify the signal of voltage for the measurement purpose. So you require to understand there are two important types of systems. One is a measurement system, which is already defined now, and the second one is control systems. So let us go to the let us go in detail about the measurement system. So we have just defined a measurement system. We require to understand, when we suppose if at all we want to go for building up of a certain measurement system, then what are the basic elements that we need to be connected? The first important is a sensor, very important part, sensor, one which senses the parameter. So when we speak about a sensor, different sensors have different designs and different principles where it is going to sense a particular type of parameter. Suppose if at all we want to go for the measurement of temperature, then it is called as a temperature sensor, thermometer as well, or a thermocouple. Suppose if it is going to measure the pressure, we call it the pressure sensor. Suppose if at all we want to go for the measurement of force, then we call it as a force sensor. So we require to understand first, a sensor is a device which is going to sense and detects the quantity being measured. Okay, that is the main importance of a sensor. And whatever the output is there, that output signal is related to the quantity being measured. That is why we take an example of a thermocouple is a temperature sensor. We consider the thermocouple as a temperature sensor which senses the temperature as an input. It is required to sense basically the temperature. Okay, then as an input it is going to sense and gives an output as an EMF, okay, related to the temperature value. Whatever the EMF means, electromotive force, which it is going to give as an output, but which is the input for the signal conditioner, as you are going to see in a block diagram. Whatever the output that we are going to get from the sensor is in the form of an electromotive force, and that is given as an input to the signal conditioning circuit. So the signal conditioning circuit, it basically it is a circuit that is designed for the purpose of manipulation. Manipulation means what? Whatever it is going to receive as an input from the sensor, it requires to manipulate, it requires to change the entire process, it requires to go for the modification of that signal that it's going to get, and then you are going to get as an output in the form of a display or controlling system, as either in the form of a display or a controlling system. For example, when we speak about a thermocouple, a small EMF is there. That small EMF which we are going to consider as an input to the signal conditioning, the signal conditioning unit circuit may be an amplifier, one which amplifies that signal and gives the output. Okay, the basic intention of using amplifier is to get a bigger signal, and it is going to act like a signal conditioning circuit. So then we are going to call the amplifier as a signal conditioner. So this is how the entire system display. When we speak about the display, it is a device which in which the output from the signal condition is displayed. Okay, it may be a pointer moving on a scale, or it may be a digital display. Now you are going to have, as far as mechatronics is concerned, in almost all the fields you are going to have a digitalized way of display. Okay, so that is important. That means whatever the display is nothing but the final output that is given by a certain measurement system. So you require to understand that a measurement system basically consists of three important elements. One is called the sensor, second component is a signal conditioning circuit, third component is a display. So all together we call it as a measurement system, that you require to understand. So this is how we are going to complete the today's session up to the control systems, and let me revise once again what we have discussed in our entire portion of the system, as we are going to see what is mechatronics, importance of mechatronics, mechatronics systems, types of systems, measurement systems we have discussed. Now in the next class we'll be discussing about the control systems, open loop control systems and closed loop control systems. That is what we are going to discuss in the next next presentation. Thank you.